We need to stop talking about curing dementia. Biologically, it is an impossible objective. Currently, 55 million people live with the condition worldwide. By 2050, that number will hit 150 million. To put that in context, someone develops the condition every 3 seconds. There is a widespread professional misconception that dementia is a targetable pathogen or a localized failure. Biologically, dementia is an umbrella term for a trailing indicator. It marks the point where massive, irreversible neuronal and synaptic death has already occurred. For decades, neurodegenerative pharmacology has failed because it treated end-stage clinical symptoms. By the time symptoms appear, 10 to 15 different biological processes have already caused permanent damage. This timeline reveals the prodromal phase, a silent, decades-long window where the disease progresses actively without outward symptoms. By the time a patient reaches their 40s or 50s, the disease is already deeply entrenched in the brain's architecture. Standard medicine currently operates at a chronological deficit. We intervene here, at the far right of the timeline, only after symptoms become undeniable. To repair the aging brain, diagnosis and intervention must move 30 years backward. We have to target midlife molecular triggers before the physical connections are severed. Most Alzheimer's diagnoses rely on subjective cognitive testing, memory recall, logic puzzles, or drawing shapes. These tests are easily defeated by cognitive reserve. This is the brain's ability to build excess capacity through education or continuous intellectual stimulation. This reserve acts as a compensatory mechanism. When neurons begin to die, the brain seamlessly reroutes signals through alternative pathways. The danger is that this reserve masks early structural loss. A patient can pass a memory exam perfectly while their brain is undergoing silent, massive degradation. Eventually, the brain reaches a tipping point. The compensatory networks run out of alternative routes, leading to a sudden and catastrophic collapse of cognitive function. Relying on behavioral symptoms guarantees a late diagnosis. We must discard subjective exams in favor of objective, quantitative biological measurements. Looking at the biological timeline at age 50, Alzheimer's begins with the asymptomatic accumulation of amyloid plaques, sticky protein clumps that form between neurons. But amyloid alone does not cause dementia. Its presence eventually triggers a second, fatal phase of the disease. In this second phase, neurotoxic tau tangles accumulate inside the neurons themselves, destroying their internal transport systems in the process. This graph shows a major breakthrough: the ability to detect a specific protein variant called phospho-tau 217 in routine blood work. Phospho-tau 217 is a version of the tau protein that has been chemically modified, causing it to clump into toxic tangles. Detecting phospho-tau 217 objectively proves the brain has transitioned into the active tau phase. These blood biomarkers allow us to bypass the deception of cognitive reserve, isolating the disease in its prodromal phase so we can deploy targeted therapeutics. Below the protein plaques lies a genetic root cause. Over 90 susceptibility genes for Alzheimer's are tied directly to the immune system. The key players in this are microglia. These are specialized, localized immune cells that act as the brain's janitorial staff. Normally, they are neuroprotective, sweeping away amyloid and maintaining tissue health. But as we age, we often enter a state called inflammaging. Inflammaging is a state of chronic, low-level inflammation where the immune system loses its ability to return to a resting state after a stressor or infection. Inflammaging causes microglia to stop acting as janitors. They become aggressively hyper-inflammatory, physically latching onto and severing neural connections. These microglia, driven by the body's complement system, begin actively destroying healthy synapses. In this view, neurodegeneration is a systemic autoimmune dysfunction. The aging brain is dismantled by its own overactive defense mechanisms. Alzheimer's is heavily genetic, but Parkinson's disease is driven roughly 70%. Understanding this shared inflammatory cascade provides a universal therapeutic vector for multiple degenerative conditions. This photograph shows the traditional, manual methods of biological research. Historically, translating a lab discovery like a new biomarker into a clinical treatment takes roughly 15 years. This chart reveals a massive disparity in focus. Cancer research has produced 5.4 million publications. Neurodegeneration has barely reached 350,000. Traditional trials are statistically difficult. Attempting to measure a subjective 30% reduction in cognitive decline over several years generates incredibly noisy data. Most trials run sequentially. If a drug fails, the entire research infrastructure is dismantled, creating massive gaps before the next trial can begin. Biological mystery is no longer our primary hurdle. The slow pace is driven by the risk-averse, structurally outdated architecture of clinical trials. The solution to this bottleneck is the adaptive platform trial. These trials test multiple compounds against a single control group. They use objective biomarker endpoints, like dropping phospho-tau levels, rather than waiting years for memory tests. This precision matrix uses monoclonal antibodies to clear amyloid plaques during the earliest stages of the disease. For Parkinson's, adaptive deep brain stimulation senses electrical rhythms to stabilize degrading midbrain circuitry in real time. Finally, new stem cell therapies can be deployed to rebuild lost dopamine networks once the inflammatory environment is neutralized. Seeking a single miraculous cure for end-stage dementia is no longer a viable scientific objective. Instead, researchers are building a multi-targeted matrix designed for the prodromal phase, arresting the cellular cascade decades before the mind begins to fade.